hack the machine again.
Again.
That's awesome.
And it's not just like again time 2.
This is like number 5.
You've done this 5 times, right?
Boston, Seattle, New York, Brooklyn, New York. Here in the spring, and here now in the fall.
So virtual here and now, like an unmanned focus. Here now.
Right. Amazing.
It's been awesome. I think, in March we did our first virtual event at this, and we had the largest registrations ever.
Yeah.
And we're on track to top that out now. We've got just under 1,000 people registered as of this morning.
Is it 1,000?
Just about.
That's awesome.
We were in high 800s, and we always see like the last minuters register like day of. So
those bell tappers. What's up with them? You've got those in the civilian world too. They're kind of in the Navy. That's right. Who's going to be here? Don't let them see me yet. Then hold off. Who's that old guy? He doesn't know how to hack.
That's over time we've done lots of things. Like we've done, but there's been a consistent theme around like the digitization of maritime capabilities, right? And so when I think back about like the first one that we did together around a problem set of yours, I don't think you joined us until Boston. I think Boston was your first.
Boston is the first one I actually went to, and I think we were kind of on the periphery, and it was really Seattle that we really got fully engaged with problems, and
And you first provided us data.
That's right. Oh my gosh.
You provided us machinery control system data when you were the chief engineer of the Navy.
That's right.
And I remember we were all liquored up because we were going to go figure out like some major analytical insight. Do you remember what we learned? We learned our data size.
Pretty much.
And there's been, and it's exciting to see, a program that you had started and Captain Black had really been instrumental to, who's here with us, kind of in the background today, was this enterprise resource management.
Which is coming to life now.
Which
I think all heavy industrial organizations are finding. The data that they've been collecting for the last 20, 30 years pretty much is not in a format which is going to actually take us into the digital future. So you've got to get that data house in order, as it were, so you can actually utilize it in a way that you can take advantage of digitization, which is what we're all trying to do. So
it's funny. So you hear that, but it's not until you try your own thing.
Then you realize,
like
wow,
this is hard. One of the old Hack the Machine events that it dawns on you, like, oh no, this is real. We've got to do something about the way we collect, tag, and organize our data.
Yeah, we're also proud of we all got computers. We're all collecting data. Yeah, maybe not so much.
And then we've done digital engineering for several years as well. And I remember back in New York, that was one of our first times to really get after that.
Right.
And it was cool. Do you remember where we did in New York?
At Brooklyn Navy Yard.
In the Brooklyn Navy Yard.
We got a history of that. It's fantastic.
Yeah. So a place where some of the most well-known ships of World War II were launched from, where we were able to run Hack the Machine.
Yeah, that's incredible.
But then, now it's set up as New Lab, as a tech accelerator, inside one of the old machine shops, and it was just so exciting that we got to go back there. And awesome. Set up a machine shop, and that's when we were doing our first time. Our first drill,
additive manufacturing, digital thread. That's right. That's right.
And again, one of those ideas that we're going to do 3D printing and advanced manufacturing. But tell us about the digial thread of that. Like, you can have a machine, but that doesn't necessarily get you a capability.
Right. So I've been saying for years that we truly have to develop, what some people jokingly call the swoosh. I've got this chart. It's a circular chart, and it's everything from concept refinement, concept development that you need to do in a digital world today. It used to be we'd write on the back of a napkin, but people now have tablets and everything else where they're scrolling stuff on digitally. That data has got to be utilized, and then when you take that from an idea to an actual three-dimensional object, whether it's first digitally, eventually physically, you've got to have a digital continuum. It's a thread, and you want to take that initial idea, maybe use some model-based system engineering, some digital design tools. As you refine that more and more, you're going to take it to a level where at some point you want to compete it for contractors to actually go build it. That data that you do maybe in-house as you do the design, at some point you want to give that to a contractor to go build. You've got to be able to flow that data without having to have an interruption and basically restarting, refat-fingering stuff into a computer. You want to flow that very seamlessly, and that's what we're trying to figure out how to do. And that's kind of the idea for the digital thread. But to truly get after digital engineering, for that idea, that flash of an idea, to the bang of a missile firing off of a future ship or unmanned platform you design and build, has got to be a continuous thread. And that's what we're trying to get after with digital engineering. And this event today, we're actually going to prove a digital track, a digital design track,
That's
which
right.
is really exciting.
Yeah, the way Track 3 has evolved over the years, we've done all sorts of digital engineering. We've done virtual reality, where we try to take digital models and wonder how they might interact with humans in a command and control context. But we're really starting to nail down, neck down in the last couple iterations about this fusion of the physical and the digital. Like you can't have like a draftsman drawn, even a CAD drawn thing that gets then printed off in drawings and then subsequently machined.
Right.
You got to connect it tighter than that.
Yeah.
And I think it's related to velocity, don't you?
Yeah, absolutely. And I think the future is going to be, he or she who can take the digital idea and morph it into a physical idea or a thing. That physical, digital, that physical, cyber, that's the future. And if you can do that faster, cyber physical, and he or she who can adapt and do that faster than someone else is going to win, whether that's in the boardroom, in a business, or on a battlefield, or on the seas. That's the future of battle space.
You've always pushed us to find challenges, and we've been so fortunate to have sponsors who actually help us fund the tracks. From across all the systems commands. We've got Naval and Admiral Rothenhaus out at PEOC4I has been an ardent
who's
supporter.
been playing in this arena for years as a program manager. It was a huge early supporter, early adopter of this Hack the Machine events.
Right,
So,
and then we've had Naval. We've got Naval participating in our X1 workshop today. They've been a sponsor of data science tracks in the past. It's a team effort, but you talk about like speed. Like we've got to get the team, I think, to like move at velocity. So you've had us out there chasing the edge, and it feels like to me the edge is starting to accelerate. Like how far we've got to jump to stay at the edge. I totally agree. Like how do you see that as this moment and the period of change?
Yeah, I think some of it is the mindset for how we actually define what it is we want to build. And I think a lot of it is we tend to use this requirements mindset, which I've been talking about for over a year now, that I think it's a great model for large, complex warships, submarines, high-end aircraft. You have to have that very well-defined requirements. You do have to take the time and due diligence to test, prototype, and then actually build. But when you're talking about digital capabilities, software-based capabilities, I think it's a different model. And I think we've got to think more about what's the problem we're trying to solve. Let's get that problem defined crisply from the warfighter, from the fleet, sailor to the Marine, and then let's go give that problem to the team that's going to solve it. It might be other parts of government, it might be academics, it might be small or large businesses. But let's present it in a different way. I think when we try to do it in a requirements mindset, I think it constrains your thinking somewhat. Whereas if you present a problem, I think people look at that and go, oh, I think I can solve that, or I might have a capability that can solve that, or I can make some tweaks to my program and I can go work with you and solve that problem. That's what we have to do. I think that will actually excite more people, get more people involved, and I think it'll actually accelerate our ability to solve problems, which is really what we're trying to do.
No doubt. As you were thinking about that, I was thinking about, we have a tendency to think about like an organization's capability to build a thing by the types of things they build. Right. And I think one of the key insights we've had over all the Hack the Machine events we've run is that you almost like slice like digitally native capabilities horizontally. Yeah. So we've had financial analysts do great in our data science tracks on Navy maintenance data. We've had all different people who are like win like various digital competitions, even though they may not have had a lot of domain expertise. Right. But when they paired with Navy scientists, and we found those synergistic teams.
And that's pairing between the scientist, the warfighter, the engineer, the technician that can help us. That's when the magic happens. I mean, think about the things we've learned from these Hack the Machine events that we never expected.
Right.
Like last in Brooklyn when that team actually caught a 3D printer on fire. Using programming, not with a match. By basically putting in a do loop so it actually just kept sending current through part of the system enough that it actually caught on fire. Who would have ever thought that? I mean, that's why these events are so powerful. You learn something every single time. And that's why you bring all these different folks in with different ways of solving problems, different ways of thinking. Now, the diversity of the teams that you bring to these Hack the Machine events, that's what you have to have. There's power in that diversity, in that thinking. So that is exactly why these events are critically important to the way I'm trying to solve problems for the U.S. Navy and Marine Corps.
So I can't wait to see what comes out of this one.
I can't either. We're going to learn something.
As always.
Thanks.
Yes, sir.